It's so interesting because I got to be honest. Like I think you guys are all like really good math students and you're good at calculus. But then when you see this lump of questions, it's a little disconcerting, right? Because you're just like, I'm not sure where to start. Let me give you a place to start. I want to just advocate for that structure I gave you guys last time. Whenever you look at one of these questions, the first thing I want you to do is like take a quick glance at the degrees, right? The degrees are going to be like a major branch in the road that you might take where you're going to go left or right. And then once you pick one or the other, then there's a few other decisions to make. But if you look at number 1, did you notice that the degree of the top is bigger than the degree of the bottom?
Oh, we can divide.
That always means some kind of division. And sometimes it's really simple division. So for number 1, the division is actually pretty simple. Other times it could be long division or synthetic division, depending on what you choose or what works better. Looking at number 1, I would always do a quick check on degrees. Degree of top bigger than degree of bottom. I'm going to do some division. My division in this case, not really going to look like division. Or at least one way you could do this. I'm going to simply flip the denominator up and make it x to the negative 2 up there. Does that make sense? Mm-hmm. Then there would be another major mistake that would indicate like lack of understanding if I started right here with my antiderivative. What do I need to do next before I do any antiderivatives? Distribute. Is that what that means? Distribute. Okay. Got to do the distributive rainbows. So this gives us x to the first minus 2 over x dx. When you multiply your bases, you add your exponents. So I was walking around, I heard somebody say, is it ln, is it this? And somebody's like, well, maybe it's ln and something else. Is it you?
That was Alex.
Was it Alex was saying that? Yeah. So this actually it does have an ln in there, but it was also some other bigger rule, right? So this would go to 1/2 x squared minus 2 natural log absolute value of x plus c for that one. Yes, sir?
So I did something a little weird. So I split up the fraction, right?
Sure.
X cubed over x squared, which just simplified to x. And then the negative 2x over x squared, I just immediately realized that was natural log. So I just did
Oh, okay.
natural log of x squared.
So yeah, let's look at this.
That's technically
Yeah, it's 100% right. So this is what Colin said. He did this, and then he said x cubed over x squared is x. And then he left this other one as is. And I'm assuming then you probably said, hey, the derivative of x squared is 2x. So it perfectly fits the chain rule with the logarithm, natural logarithm pattern. So you got 1/2 x squared over here, of course. Then you got natural log of x squared plus c. How is that the same as this? The 2 gets to migrate on down the front, the power rule for logarithms. Got it. So these logs can get a little... Oh, of course. Yeah, they're equivalent. And some of these logs, you can get even more complicated ones too, kind of along those lines. Let's just do number 2. We'll finish with this. Did you guys all, like if you're not in the habit of doing what I'm about to do, I really think you should get into this habit. Are you guys bringing the 2 out? The constant multiply, I really think you ought to do that. That potentially clears up some confusion. So then with this one, the degree of the top is clearly not bigger than the degree of the bottom, so some kind of division is not in play here. So then I start to ask myself these questions. Is it natural log? To check that, I ask myself, what's the derivative of the denominator? In this case, it's 8x. Compare it to the top. We're off by an 8, which is not a big deal. We're off by an x, which is. So it's not natural log. Flip up. Flip up would give us something like this. And what is the problem? What is one of the problems with that? Adding 1, you're going to end up dividing by 0, right? And then also the derivative of the inside is not the other factor. So it's not flip up for a couple of reasons there. So you're left at this point with arctan or arcsine of those 2. Which would it have to be? It would have to be arctan. So if it's going to work out, your u would have to be 2x. Your a would have to be 3, and of course then your u prime would be 2. So for this to perfectly fit the arctan pattern, the numerator has to be what multiplication? It's got to be 6. It's got to be 6, right? It's got to be u prime a. So 2 times 3 is 6. So the numerator has to be a 6. It's not, but we can fix it. So I just go times 6 divided by 6. I would finally end up with 1/3 arctan of 2x over 3 plus c. So you can see how these can take all these radical turns and twists and shifts, right? Just based on little tiny details. Question, Liz?
I did it really different.
I'll check it out here in just a second. Are you guys good to go? We'll complete all this stuff on Monday, so don't forget to bring your Chapter 8 notes with you on Monday. Have a great weekend. Thank you. See you, Josh.
But I was looking at